Okay, we'll begin now. One more time, welcome back. So today we are going to begin module 2, and here we'll be talking about frequency distribution and graphs. Okay, so what we have seen in our previous class or last week is we learned about statistics, and we know that statistics is the branch of mathematics where we talk about the first thing is the collection of data, right? And the way we collect the data is using different sampling techniques. And we have seen that in last class. Second thing that we do in statistics is we organize and present the data. So that is what we are learning today. We are learning how to, say that again? You have to print yourself and bring it. Yeah. Okay, you can go to the hub and print right now if you want. It's just on the other side. So yeah, so what we are going to do is we are going to look at the way we are organizing the data, that is using the frequency distribution. And the other one is graphing that, that is the presentation of the data. So we are looking at those two big things now, okay? So first one, in the organization of data, we have frequency distribution. We can organize the data using frequency distribution. Frequency distribution is one of the methods of organization of the data, okay? We have seen in previous class, there are two different types of data, qualitative data and quantitative data. If the data is qualitative, we make categorical frequency distribution. So this one, categorical frequency distribution, this is for qualitative data. This is for qualitative data. And then the other two that we have here, that is ungrouped frequency distribution and grouped frequency distribution. These two, okay, these two are for qualitative data. No, sorry about that. The first one is the qualitative. These two are for quantitative data. Quantitative data. So when I say qualitative data, these are non-numerical data. And when I say quantitative data, these are the numerical data where you see the number, okay? Yeah. Now, as you can see, there are two different types in qualitative data. We have ungrouped frequency distribution and grouped frequency distribution. We use the ungrouped frequency distribution for a small data size. Okay, for a small data size. When I say small, the size should be less than 30. If the data size is 30 or less, we use the ungrouped frequency distribution. But if the data size is more than that, we use the grouped frequency distribution. So this is for large data size. This is for large data size, where n is greater than or equal to 30. So one more time, one of the methods of organization of the data that we are exploring in this unit is frequency distribution, okay? And the frequency distribution, as you can see, they are of three types. The first one is the categorical frequency distribution. That is for qualitative data. If the data is non-numerical, we use the we use the categorical frequency distribution, okay? And then for the quantitative data or numerical data, and if the data size is small, we use ungrouped frequency distribution. If we have the quantitative data that is large, 30 or more, we use the grouped frequency distribution, okay? So let's begin with the first one. Here is our first example. Look at this. In this one, we have an organization surveyed 50 randomly selected individuals and asked them the primary way they receive the daily news. Their choices were via newspaper, denoted by N, television, denoted by T, radio denoted by R, internet denoted by I. We are asked to construct a categorical frequency distribution here. So let's see how we can make that categorical frequency distribution. Here you can see that the data does not involve number, right? You have either N or I or R or T, right? So what do? Let's make a table. That is where we begin. Okay. So we have the sources of news. We write the sources and we write the frequency. Frequency means number of times something repeats. And here our data is so we just have to list the different sources, that is newspaper N, we have the television T, radio R, and internet I. Then we count. Frequency means number of times something repeats. So the first one is the newspaper. So you have to count how many N are there. So 1, 2, 3, I'm counting 4, 5, 6, 7, 8, 9, 10. Right? I got 10 of them. So I'll write 10 there. So you have to count and then write the frequency. So newspaper, we got 10, right? Now, similarly, count the remaining, count the television, radio, internet, and complete that table, please. While taking notes, make sure you use pencil so that if you need to erase and rewrite it, that will be wonderful. Pencil is best for taking notes in math class. Okay. So I know you got these values. So how many people get the news through television? 16, okay. How many use radio? 12. And how many use internet? 12. So total, when you add all of them, what you'll get? 50. So sample size N is equal to 50. Okay. When you add all of them, that is the sample size N is equal to 50. So if you look at this table, what we have done is you have so much data there, right? And we have written just N, I, R like that, as you can see here in the screen, right? So much data is given. So that data is not arranged. That is the raw data. That is the data after we collect it. Now what we have done is we organize the data in the form of a table here. So this is the frequency table, okay? And this frequency table is for non-numerical data like newspaper, television, radio, and internet. So this one is called categorical frequency distribution. Categorical frequency distribution. So that is the first way of organizing the data by making a frequency table here. And this one is for non-numerical or qualitative data. Any question on this one? No question? Student in the virtual classroom, if you have question, you can unmute yourself and ask. Okay, if you have no question on this one, we'll move on to next one. So this one is on group frequency distribution, because here the data is a small numerical data. Okay, if you have a small numerical data, we use grouped frequency distribution. So the question here is the blood urea nitrogen denoted by BUN, okay, BUN count of 20 randomly selected person is given here in milligram per deciliter. We have to construct an on-grouped frequency distribution for the data. And after you construct the on-grouped frequency distribution, there are two things you are asked to do. You have to find the cumulative frequency and relative frequency. Make sure you check in your note catcher. You have to find the cumulative frequency and relative frequency both, okay? If something is missing, you add it. Okay. Now what we are going to do is, just like in the previous example, we are going to make a table to fit all this information. Okay. Let's make a table. So what we'll do here is I'm going to write X for the data values. Okay, I'm going to denote the data values by X. We need the frequency because we are making the frequency table. So next column will be F for frequency. In the question, we are asked for the cumulative frequency. So next one, I'm going to write CF for cumulative frequency. And the last one is we need relative frequency. I'm going to write RF for relative frequency. Now, if you look at the data, you'll see different numbers. The smallest number that I can see is 11. Please check it. We also have a 12 there, right? Next, we have 15. There is no 13 or 14. There is 15, no 16 or 17. I can see 18. There is no 19. There is 20, right? So we can write those numbers like that. And down there, we'll add a row for total. Now, what you have to do is we have to count and write the frequency. So first, I'm going to count how many 11 are there. It's 1, 2, 3. I just see 3. Is that right? Okay, there are 3, 11. Now, please count the remaining and complete the table. Count the remaining and complete the table. How are you? You have to print it yourself. Yeah. Yeah, I just printed the first one, right? Yeah. Okay, I hope you have those numbers now. So when you count, how many 12 are there? 4 of them. That's correct. How many 15? 3. How many 18? 6. And how many 20? And did you add all of them? 20. So n is equal to 20. Yes. N is the sample size. N is the sample size. When you add all frequencies, you'll get n, that is 20. So like here, how many individuals are selected? 20, right? So n is the sample size. Yeah. No, so for the sample, we write lowercase n, and if it is the population size, we use the uppercase n. Yeah. Okay, now we'll find the cumulative frequency. Okay, so cumulative means you are adding together. For example, if you look at the screen, I'll be using mouse here so that the student in Zoom classroom can also see. So how many 11 are there? 3, right? So we write 3. Cumulative means total. Now, if I go here in the second line, how many are there if I count 11 and 12? 7. 3, 11 and 4, 12. So that will be 7. That is cumulative. Now, if I go to the third one, what I'm doing is I'm counting how many 11, 12, and 15 are there if I add all of them. What is that equal to? 10, right? 10. Yes. 10. Let me write it down. So what will be the next one similarly? 16, and the last one will be 20. So you can see that that last value should be equal to this 20. So those two numbers must be the same. Okay, and you don't need to add cumulative frequency, because by adding cumulative frequency, we don't get any significant thing. So you don't need to add that. Now, finally, we go to relative frequency. When we say relative frequency, it is the ratio of frequency to the total. So it is the frequency divided by n. Relative frequency is frequency divided by n. It is the ratio of frequency to the total. So we write relative frequency is equal to f divided by n. So if you look at the first one, our frequency is 3. Do you see that? There is a 3, and we divide by the total. What is the total there? 20. 3 over 20. 3 over 20 means how much? 0.15, right? 3 over 20, 0.15. Now the next frequency is 4, as you can see. So it is 4 divided by 20. 4 divided by 20 is 0.20. Next frequency is 3. So 3 divided by 20. 3 over 20, you already know that's 0.15. Next one is 6. Frequency is 6. So 6 divided by 20. 6 divided by 20 is 0.30. And finally, we have 4. So 4 divided by 20. 4 divided by 20 is equal to 0.20. So this is how you can find the relative frequencies. Now you'll see something. If you add all those relative frequency, please add and check what you'll get. 1. That is right. Now this relative frequency has a special meaning. For example, look at the first one. We get a relative frequency of 0.15. Meaning of that is 50% of the given data is 11. Makes sense? 15% is 11. Similarly, if I look at this number here, 0.30, 30% of the given data is 18. Okay, that's why when you add all these relative frequencies, you get 1, which is 100%. Okay, so relative frequency represents the percentage of data that is present in the given distribution. Okay, and as you can see, the data size is small here. We just have 20 of them. Small data size. We make the frequency distribution here. This is a small frequency distribution, which is ungrouped. Okay, we don't use any grouping here. So that's why this is called the ungrouped frequency distribution. Ungrouped frequency distribution. Any question on this one? Yeah. Because by adding the cumulative frequency, we don't get anything meaningful, so we don't need to add them. If we get something meaningful, we would always add. But cumulative frequency, by adding cumulative frequency, we don't get anything meaningful anytime. So you don't need to add those cumulative frequencies. Yeah. Any other question like that? Students here in the Zoom classroom, if you have question, you can unmute yourself and ask. Okay, now let's move on to the next one. So this time we are looking at a large data set. Okay, so here is our large data set. And what you have to do is we have to create a grouped frequency table from this one. Okay, grouped frequency table from this one. So let's read the question. What are they asking here? The ages at the time of death of those vice president of the United States who have passed away are listed below. So these are the ages of the vice president who passed away, and these are the ages recorded at the time of their death. Okay. Use the data to construct group frequency distribution. We have to group the data into smaller groups and make the frequency distribution. And how many groups we are asked to make here? 6. We are asked to use 6 classes or 6 groups. Okay, we are asked to make 6 classes or 6 groups. So if you look at the data carefully, what is the smallest data value here? 51. Okay, so that means the data is from 51 up to, what is the largest? 98, right? 96 or 98? 98. So we are going from 51 up to 98. 51 up to 98 means what is the difference there? 47. But if we count 51 and 98, it is 48, right? So there are total of 48 values included between that. For example, if I go from 2 up to 5, how many numbers will be there from 2 up to 5? 2, 3, 4, 5, right? 4. It's not 5 minus 2, 3. It's 4, in fact. So just like that, if you subtract here, it will be 47, but there are 48 values there, right? And we want to divide these 48 values into how many groups? 6. So divide that by 6. And 48 divided by 6 is how much? 8. So we want to have 8 numbers in each group. Does that make sense? We want to have 8 numbers in each groups. Now you can see that we are going from 51 up to 98. If you want to start at 51, that's perfectly fine. If you want to go a little bit below and start at some other number, that's also fine. Okay, so for me, 50 looks better number than 51, so I'm going to start counting from 50. Is that okay? So that 51 is included. If I go a little bit above 98 at the end, that's also fine. Okay, but we want to mix classes with at least 8 elements in each. So let's try. Let's make a table. Okay, I'm trying to make a table here. Okay. I'm going to write the class on the top. Okay. And we are starting at what number again? 51, but I'm starting at 50, right? Yes. Why do we label it as what? Because we are using the classes there, 6 different classes or 6 different groups. But in that group or class, what goes in that group or class is the age of the vice president. Okay. So we start at 50. We start at 50. And if I want to include 7 of them, I mean 8 of them, what will be the next number? 50 up to how much? 50 up to 57. 50 up to 57. You can count on your finger. 50, 51, 52, 53, 54, 55, 57, right? 56, 57, right? So when you go up to 8, how many you are? How many you have? If you go up to 58, you'll have 9, but we want only 8, right? So we go up to 57. Does this make sense? See, let me show you here. 50, 51, 52, 53, 54, 55, 56, 57. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? That's why. Okay. So similarly, the next, so this is one group because we are making the grouped frequency table, right? This is our first group. Now you have to count. You have to count how many numbers are between 50 and 57. For example, if you count between 50 and 57, between 50 and 57, this is 1, this is 2, between 50 and 57. We are looking for the numbers that are between 50 and 57, inclusive. Including, yes, inclusive. 50 and 57, inclusive. What do you see? How many are there? 5 of them. So that is the frequency, 5. Okay. So do you understand the process now? What you have to do is you have to make the group, okay? You have to make the group and you have to count how many are there. So I'm going to finish writing all the groups and I'll ask you to count after that, okay? Okay, now the next one is from, we go up to 57. So what is the next number? 58. If I want to have 8 of them, we go up to 65. The next one will be from 66 up to 73. The next one will be 74 up to 81. And the next one will be 82 up to 89. And then the next one will be 90 up to 98, right? 97. It will be 97. But if I do 97, I will be just left with one data value at the end. Yes or no? 98. So I can include that there, 98, in the last one. Because if I want to make another column, I mean another group, I'll have, pretty much empty thingy, right? Just one element there. So I just include the last one there. Could you please count each of them and complete the frequency table now? I know it will take a little bit of time. I will give you that time. Make sure you count properly and then fill the table. Okay. I also counted those values. And here are the correct values. You can look at the screen, check it whether you have counted properly or not. If you get something different, make sure you recount them later on at home. So we get 58 to 65, 5, 66 to 73, 13, 74 to 81, 10, 82 up to 89, 3, and 90 up to 98, 4. Okay. And if you count all of them, that will be 40. Because if you count the number of data pieces up there, we have 40 of them. Okay. So we got the class or the group and the frequency. Now the next two things we want to find here, they are the cumulative frequency and relative frequency. So you know the idea of cumulative frequency now. So please help me write those cumulative frequency. So for the first row, what is the number? 5. The next one will be 5 plus 5, that is 10. 10 plus 13, 23 plus 10, 33 plus 3, 36 plus 4, 40. So as I said, that last value should be equal to n. We got that, right? Those two values are exactly the same. Okay. Then after that, the next thing we want here is the relative frequency. So if you remember, relative frequency is frequency divided by n. So for the first one, frequency is 5. 5 divided by 40. Right? 5 divided by 40. So how much is 5 divided by 40? 0.125. It's 5 divided by 40, 1/8, right? 0.125. Next one, again, we have the frequency of 5. So that is also 5 over 40, which is 0.125. The next one is 13 now. So that is 13 divided by 40. Okay, 13 divided by 40. How much is 13 divided by 40? 0.325. That's correct. Okay, next we have a 10. So it will be 10 over 40. 0.25. Next one is 3. 3 divided by 40 is how much? 0.075. Finally, we have 4 out of 40 is 0.1, right? 0.1 or 0.100, however you want to write it. Now, if you add all those frequencies again, what you'll get? You'll get 1. Okay, you'll get 1. Because the sum of relative frequency is always 1. And if I want to know the meaning of this one, say, for example, this number that I'm pointing here, 0.125, that means 12.5% of the data is between 58 and 65. That is the meaning of that. So this is the example of grouped frequency distribution. So this is grouped frequency distribution. Grouped frequency distribution. Any question on this example? No, it's pretty much making the groups and counting, right? Okay. Wonderful. So these 3 examples, these are based on the organization of the data. So once we collect the data, because when you go to field and collect the data, we just get the numbers like that, right? We just get the information on a sheet of paper. Then what you do is we organize the data so that it looks neat like that in the form of a table, so that it's much better to read compared to that large set of data. Okay. Now, the next thing we want to explore in this chapter is the presentation of data. How we can present the data. We can present the data by making different types of graphs and charts. Okay. And first is the histogram. Before we go to the histogram, let's quickly look at this example on the grouped distribution. Grouped frequency distribution is given to you, as you can see, 50 to 55, that's one group, 56 to 61, another group, we have the frequency. Just like the frequency table we have created in the previous one, they have given this one. And we are asked to answer these 3 questions. And all these questions are based on third class there. So this is the first class, this is the second class, this is the third class. So our focus is here on the third class, this one. We have to answer the question based on that third class. So first question is, we have to write the class boundaries for this class. What do you think is the class boundary for this class? It is from 62 up to 67. So we can write 62 up to 67. Okay, 62 up to 67 there. And then the next one is, we have to find the midpoint of the class. Do you know how we find the midpoint of the class? Any idea? Say that again. Same as the median? Yes, but how do we find it? Right. Or basically, you can also add the lower and the upper boundary and divide it by 2. That's another way of doing that. So we can do 62 plus 67 and divide that by 2. Okay, and if you add those two, you get 129. You divide it by 2, you get 64.5. That is the value in the middle. Okay, value in between 62 and 67 is 64.5. So that is the midpoint of the class. We need a midpoint of the class to find the average values of the distribution, and we'll use that in third module. Next one is the class width. What is the width of the class, or how many elements are there? If we go from 62 up to 67, 6. Right? If you count 62, 63, 64, 65, 66, 67, 6 of them. Okay. Any question on this example? No. So let's talk about histogram then. So this is the first way of presentation of data. Remember, there are different types of data that we have seen in our previous module, right? This one, histogram, is exclusively for continuous data. Okay, histogram is for continuous data. So this one is for continuous data. This is for continuous data. And in histogram, what you do is we draw the vertical bars. As you can see here in these 4 different histograms, we draw the vertical bars. Okay, and these vertical bars should be connected. Means they should be joined. Okay, you have one vertical graph, the other one is attached to that, just like this example here. The height of the bar is proportional to the frequency. So what is the height of, for example, this bar where I'm pointing? It should be equal to the frequency. Whatever is the frequency, that will be the height. That's how we draw the histogram. Okay, so let me quickly show you how we can draw a histogram. Then we can come back to this slide and discuss a little bit more. So let me go to example 6. Did you find that example? Example 6. So if you look at the data given there, you can see we have the temperature in the month of July, and we are asked to construct a histogram to represent that data. So now, if you look at the temperature in the month of July, we have 55 up to 60. Without a break, the data is continuous. We are going from 60 up to 65. Again, without the break, so that the bars will be joined, 65 up to 70, and so on. So what we'll do is, we'll plot all this temperature along the x-axis, and then the number of days or frequencies along the y-axis, and we construct the histogram. Okay, so let's begin. Let's first draw the x-axis. So I'm drawing my x-axis here. Suppose that is my x-axis. You can start at 55. 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. These are the temperatures in the month of July. These are the temperatures. Okay. Now, along the y-axis, you should have the frequencies. So we draw the vertical axis here, like that. And in that vertical axis, we need to have frequencies. And if you look at the given table here, you can see that the maximum frequency is 10. Okay, we want to go up to a maximum of 10. So I'm going to count by 2 here. 2, 4, 6, 8, and then 10. And remember, between those numbers, for example, between 0 and 2, there is a 1, then there is a 3 in the middle, 5, 7, 9. You got that, right? Okay. Now let's make the vertical bars to create the histogram. So if I want to make the vertical bar for this two group, look here, 55 to 60 or 60 to 65, both has the frequency of 1, right? That means for both, the height should be 1. So I'm going to draw those two bars together. Height of 1. There we go. So I'm drawing two of them together. See, there's 1 there. And the frequency is 1 and 1 for both. Now, the next one, you can see for the next one, 65 to 70, the frequency is 4, our height is 4. So 65 to 70, the height should be 4. That is 4. So if we keep going like that, next one, height is 5. So let's make that a height of 5. Next one is the tallest, height of 10. Because the maximum frequency is 10. Like that. Next one has a height of 4. So we draw the next connected bar, height of 4. Now we have the next one, 85 to 90, height 3 or frequency 3. 85 to 90, frequency is 3. '90 to 95, frequency 2. And then finally, we have 95 to 100, frequency 1. There we go. So that is the histogram. So you can see that we constructed represent the histogram. And the data here is the temperature in the month of July. Remember, temperature is the continuous variable, right? So because it is the continuous variable, we can represent the data like this using histogram. So this diagram that is created here, this is called histogram. Now, in the same question over here, you can see we are asked to state the shape of the distribution. Do you see that? We are asked to state the shape of the distribution. I'm going to come back later on and answer this question. Let me go back to the previous slide now. We were talking here. So this is about the continuous data. We have several examples of the histogram here. And if you look at this, we'll be able to understand the shape. For example, the first one, if I look at the height of all the bars, look at the first one. If we look at the height of all the bars, they are pretty much the same. uniform, right? Same throughout. That's why that type of data distribution, it's called the uniform distribution. Okay, that's called the uniform distribution. Now, if you look at the next one here, this one, if you look at the tallest bar will be the reference. If we look at the tallest bar there, what we see is we have less data on the right, on that side, we have less data, but on the left, we have so much data, right? More data is on the left. If more data is on the left, what do we call for that type of distribution? Left skewed. The data is left skewed, more data on the left side. Okay, that is the meaning of that. If you look at this one now, the second one, there is the tallest bar. Let me show you with the red dot there. So there is the tallest bar. And if you look at the data on the left-hand side, we have only that much data on the left, little, right? But on the right, we have more data. If more data is on the right, we call it right skewed. Okay, the distribution is right skewed. Now, finally, the last one, you can see that the tallest bar is there, right in the middle, and we have pretty much the same amount of data on the left and the right. If we have pretty much same amount of data on the left and the right, we call this distribution a normal distribution or symmetric distribution. We'll get to that in a minute, right? Okay, so this one is called the normal distribution or symmetric distribution, and this shape is sometimes called bell-shaped. This is sometimes called bell-shaped. So by looking at the histogram, we can tell the distribution. What type of distribution is that? Is it a normal distribution or is it a skewed distribution? Or maybe it's a uniform distribution, right? So that is the power of histogram. We can look at it and we can easily answer the shape of the distribution. Any questions so far on this slide? Yes. You can write any, but the famous is normal distribution. Students in the Zoom classroom, I just sent a link for the attendance. Please complete your attendance there. Okay, now let's go to that example 6 that we are looking at. What do you think about this distribution now? It is pretty much normal distribution, right? Because we have the tallest bar in the middle and we have almost equal amount of data on the left and equal amount of data on the right. You can count, they are approximately the same, not exactly same, because on the left of this 10, how many data values are there? 5 plus 4, 9, 10, 11, right? And on the other side, 4 plus 3, 7, 8, 9, 10. Is that right? So pretty much the same. So we say that this distribution is approximately normal. I'll call it approximately normal distribution. Okay, approximately normal distribution. Okay, let's answer some of the questions based on the histogram now. So if we look at this one, here we are talking about the shape of the distribution. What can you say about the shape of the first histogram in this picture? It looked like a normal distribution, right? Okay. So let's call it normal distribution. What can you say about the shape of the second distribution there? Left skewed. Very good. Left skewed. Any doubt on those two? No? Okay, that's the easy one. Now, I have one more here. Example 7. Use the histogram to estimate. I use the word estimate because we may not be able to get the exact value, right? Because it's not scaled properly. So I said approximate. So did you find that example in your note catcher? Just flip the page. You'll see it. Okay. We have to estimate the size here, or the sample size, I should say. So if you look at the diagram carefully, what is the frequency for this first bar? 55. What is the frequency? How tall is that? It's less than 5. So yeah, 3 will work. Okay. The next one, you said 5. What is the height for the next one? 15, right? Exactly 15. The next one, I see it is a little bit above 25, right? 27. If I go to the next one, it is more than 40, but somewhat close to 45. So 43. This one is exact, right? How much is that? 30. Very good. Look like this one is also exact. How much? 20. And then this one also looks exact. What is that? 5. So you want to find the sample size. So the total will be equal to, you just add those numbers. 3 plus 15 plus 27 plus 43 plus 30, right? Plus 20 plus 5. So if you add all that, you get the sample size n equal to, when you add all frequencies, please add and tell me what we get. 143. Okay. 143. So the sample size is 143. So if we quickly recall what we have done so far, we work on 2 things, right? The first one is organizing the data. We learn how to organize the data using the frequency table. If the data is non-numerical, categorical frequency distribution, right? If it is numerical and the data size is small, ungrouped frequency distribution. If it is numerical but the data size is large, we use the grouped frequency distribution. That is the organization of the data. Now, this one we have just covered. This one is the presentation of data. And here we are presenting the data using histogram. Remember, histogram is exclusively used for continuous data set. Okay, here the vertical bars are connected to represent the continuous data, and height of the bar is proportional to the frequency. If the frequency is more, the graph will be taller. Okay, the bars will be taller. Okay, and the powerful thing that you can see from the histogram is it will tell you the shape of the distribution, whether the data is left skewed or right skewed, or the data is normal or maybe uniform, right? We can tell all this information just by looking at the histogram. Okay. So with this, what we are going to do is we are going to end for today. But wait, you are not going right now. So we are going to end the class here. Let me formally stop this recording portion.